Hello, welcome to my channel. In this video, I'll be talking about accuracy, errors, and significant figures in measurements. These are important topics in JAMB UTME syllabus, and we need to look at it. Accuracy refers to how close a measured value is to the true or accepted value of a quantity. Is a measure of an instrument's ability to give results that is free from error and reflects the actual value as closely as possible. Accuracy and precision are different. Accuracy tells us how close a measurement is to the true value. For example, let's say the distance here between here and here is 25 centimeter. Let's say we now measure this value with a ruler or whatever measuring instrument. Accuracy is how close our observed value is to this 25 centimeter. If the value is 24.9, we say it's accurate. This is more accurate than a value of 23 because this is closer to the value, which is 25 centimeter. If the value is 25.2, it's closer to this value. So this is more accurate than 23 because if you look at the error margin between them, is less here. So accuracy is how close our observed value is to the true value. While precision, on the other hand, refers to how consistent a measurement is by an instrument. Let's say we measure this, let's say we use an instrument to measure a distance and it gives us 24, 25, 23, 24.5. This is more precise. The precision for this instrument is higher than an instrument that gives us 20, 25, 26, 30. Okay, you see this one, the closeness of the several observed value is more here than here. So this instrument is more precise. The precision is higher here. Okay, that is the difference between accuracy and precision. This formula is used to calculate accuracy of an instrument. Master the formula as you may need it in exam. Errors refer to the deviation or difference between the measured value and the true or accepted value of a quantity. There are different types of error. There is systematic error, random errors, gross errors, and their definition are under them. Systematic errors is due to the flaws or problem with the measuring instrument. Okay, and it's usually consistent and predictable. Of course, that is because the instrument that's measured the distance to be 100 centimeter. Even if that instrument is faulty, it will still be measuring 100 centimeter. If you measure it several times, maybe or 99.9 centimeter, so it will be precise. Okay, so this type of errors is usually consistent and predictable. Okay, now it's usually consistent in the sense that it occur again and again, while random errors occur due to unpredictable variations in experimental conditions. And the magnitude usually vary and also the direction, okay, because it is unpredictable. Take notes. Systematic error is usually predictable and consistent, while random error is unpredictable, okay, and the magnitude and direction varies, okay. Gross errors results from human mistakes like problem with recording of the results. And also, if someone doesn't know how to read a scale very well, whatever error that results from that is gross errors. Simple estimation of errors involves quantifying the uncertainty in the measurement by identifying and calculating the possible deviation from the true value. All these definitions, you may not mind them much because it's very unusual for them to ask for definitions in JAMB. Okay, but it's very important for you to understand the concepts. Okay, now there are different ways we can evaluate errors in measurement, and one of the ways, one of the type of error that we can estimate is absolute error, which is simply the difference between the measured value and the actual value. If the value, if the true value of a distance is 50 centimeter and the measured value is 49.8 centimeter, the absolute error is calculated by subtracting the measured value from the actual value. Okay, and this will give us 0.2 centimeter. Okay, that's the absolute error. 50 centimeter minus 49.8 centimeter. That's our absolute error. Relative error is the ratio of the absolute error to the true value expressed as a fractional percentage. So, relative error is absolute error divided by true value. Okay? So, if you want to calculate the relative error for the this previous example, that will be 0.2, which is the absolute error, divided by 50 centimeter, which is the actual value of the distance measured. Okay, and this can be expressed as a fraction or it can be expressed as percentage. Okay, and if you look at this will be equals to 0.004. Okay, by ratio, right? And it will be 4, it will be 0.4%. So this is relative error, and that how to calculate it. Percentage error is relative error expressed in percentage. Okay, and the mean absolute error is usually a kind of error that is calculated when you subtract the measured value from the actual value. When you measure several times and you do this calculation repeatedly for the different value that you got, then you add all of them together and divide it. You get the mean absolute error. Okay. The next thing we talk about is significant figures, which indicate the position of a measurement. Significant figures is very important in physical sciences as it helps in assessing the position of the measurement. Okay. Now, there are rules that guide how to count significant figures. And these are the listed rules. The first rule is non-zero digits. All non-zero digits are significant. Okay. For example, these three, these are non-zero figures, and there are three. These three significant figures. Zeros between non-zero digits are significant, as seen here. Okay. So the number of significant figure here is one. This is significant. This is significant, and this is significant. Four. Okay. Next rule is that the leading zeros that precede all non-zero digits are not significant. They only serve as placeholder. Yes. Look at this. If you look at these zeros, the leading zero before the significance figure in the decimal number are non-significant. So therefore, this one has two significant numbers. Trailing zeros, that's zeros that come after a decimal points, after the end of a number, after a decimal point. Trailing zeros in the decimal number, that's the zero at the end of a number after a decimal point. These numbers, these zeros are significant as seen here. Okay, you see this zero come after the end of the number. Okay, so this zero is significant. Therefore, this is three significant figures. On the other hand, please take note. If there is no point here, let's say there's no decimal point here, okay, and you have this number like this 450. How many significant figures are this? This is two significant figure. The reason is that this rule apply to decimal numbers. In non-decimal number, the zeros that follow the end of the non-zero numbers are usually non-significant if they are not between non-zero numbers. For example, if there's another number here like 2, then this zero becomes significant. Take note of that. Now, when doing calculation with decimals, it's important to follow some rules. Rule number one is when you are doing addition and subtraction for decimal numbers, the number, the result, your result should be expressed in the same number of decimal places as the measurement with the fewest decimal places. If you look at this example, this one has two decimal places and this one is one decimal place. Your result should be expressed in one decimal place because that is the least decimal places. Multiplication and division. If you are doing multiplication and division with decimal numbers, your result should be expressed in the same significant number as the number with the fewest significant figures. Look at this example. These three significant figures and these two significant figures. Your result should be expressed in, sorry, this is three significant figures and these two significant figures. Your result should be expressed in two significant figures. That's the rule. Why are we talking about significant figures? It's all about accuracy and precision, and also to ensure clarity of communication when reporting or interpreting data. And also, the proper handling of significant figures help maintain consistency and avoid overestimating the precision of results. Having talked about all these topics, let's go through some questions to test our knowledge and also to reinforce the lesson we have learned in this topic. Okay. Question number one: which of the following defines the accuracy of a measurement of a measuring instrument? A. You know, accuracy and precision. Don't forget, accuracy talks about how close the measured value is to the true value, while precision talk about how consistent an instrument is, how consistent the value measured by an instrument is. Okay. Now, which of the following defines the accuracy of a measuring instrument? A. How close a measurement is to the true value. That is correct. Okay. How consistent repeated measurements are. This is precision, not accuracy. The smallest units and instruments can measure. No, that is not correct. Okay. The range of measurements and instruments can take. That's not correct. The correct answer is A. Next question. The thermometer has an accuracy of plus or minus 0.5 degrees Celsius. If it reads 37.5 degrees Celsius, the actual temperature could be A. When you see a reading written like this, 37.5 degrees Celsius plus or minus 0.5 degrees Celsius, usually the units will be at the end. Okay. This is the accuracy and it gives us the range that the value could be because no instrument is actually perfect. No measurement is perfect. So, but the accuracy will tell us the range in which the true value falls. And that is what is here. Is it plus or minus 0.5 centimeter? So for us to get the range, it will be 37.5 plus 0.5 between this between this and 37.5 minus 0.5, which is what? This is 38 and this will be 37 degrees Celsius. Okay, so the range will be between 37 and 38 degrees Celsius. So the correct answer is B. What is the accuracy of a balance that consistently reads 50.5 gram for a 50-gram standard weight? The accuracy for this value for this instrument will be 50 minus, sorry, 50.5 minus 50, which is equals to what? Which is equals to 0.5. So plus or minus 0.5. That is the accuracy of the balance. Question number 4. If a measurement is reported as 25.25 plus or minus 0.5 centimeter, the percentage error is, how do you calculate percentage error? The percentage error is this absolute error, okay, divided by the true value times 100. Okay, that's the percentage error. You know, 0.5 divided by 25. This is the same thing as relative error, which can be expressed as ratio like this. And this 0.5 divided by 25 can be expressed as ratio like this. But what we are asked for is the percentage. So we have to multiply it by 100. Here 1, here 4. So this will be equals to 2%. Okay, the correct answer is A. Which of the following represents an absolute error? Absolute error is usually represented by with plus or minus. Okay, then like this. So this is the correct answer. This can be a relative error or percentage error. Okay, this is just a reading, and this doesn't really connote any meaning. Number 6. A scale has a least count of 0.1 gram. What is the maximum error for a single measurement? The maximum error for a single maximum error is equals to least count divided by 2. Least count is usually when you have a meter rule like this, that say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. This is 0.5. So let's say this ruler is in centimeter. The least count is this small dot. Okay, if you want to get the maximum error, you divide the least count by 2. You know, this one will be 1 millimeter. Okay, this one will be 1 millimeter in this figure now. So that is the least count. Now to get the maximum error for an instrument, it will be the least count divided by 2. And if you look at it, it's equal to 0.05 plus or minus 0.05. That's the maximum error. Okay. Next question. How many significant figures are in the number this? Now, let's use the rule that we learned in uh, assigning significance to a figure. The leading zeros are usually non-significant in decimal numbers, right? And non-zero numbers are significant. So this one and this one are significant, right? They're making 2. Now, this 0, that's the trailing 0, that's usually significant in decimal number but not significant in non-decimal number. For example, for a number of 340, okay, this is two significant figure, okay, but in this case it is three significant figure because this 02 is significant. So the correct answer is B. Okay, so take note of these rules. Which number has a five significant figures? Let's look at it. Option A. These zeros are non-significant. This one is significant because it's not zero. This one is significant because it's not zero. This one is significant because it's not zero. This one is significant because zero that trail decimal numbers, the numbers in decimal numbers. So this is 4. This one, how many significant figure is this? Guess. Oh, you guessed right. This is three significant figure because don't forget the rule. This is not decimal number. So these zero are non-significant. So they are, this is three significant figure. Okay. Option C. These are non-significant. These are significant. This is significant. So this is four significant figure. Now look at this. All the numbers are significant. This one is significant. This three. This is three. This is two. That is five significant figure. So the correct answer is D. In the calculations, this the result should have how many significant figures? Don't forget when you are doing multiplication with decimal numbers, the result should have the same significant number as those as the number that has the least significant figure. And if you look at this, this is three significant figure and this is two significant figure. So your result should be in two significant figure. The correct answer is B. Next question. If a number with three significant figures is rounded from this to three, if a number with three significant figures is rounded from this, what will be the value? Look at this. This is how many significant figures? That is five significant figures, right? Good. Now I want to convert it to three significant figures. So what we'll do is we'll get the first three significant figures. One, two, three. That is 0.12. We're supposed to write 3 here, right? But if you look at the number that follows, it's 5. So when you have 5 and above that follow the last number, you round up to the upper digits, which is 4. So what we write here is 4. But don't forget, if it is less than 5, it will be 3. Okay? So the correct answer here is A. Okay? Thank you for listening. Please like, share this video for it to go viral and for others to benefit, and subscribe to my channel to encourage me to make more videos. Click the bell sign for so that you'll be alerted when I upload new videos. Comments below, let me know how you feel. If you have a topic that you think I should do a video on, let me know. Okay? Thank you for watching. You are well appreciated. Until I see you in my next video, take care. Bye bye.